Today, let's talk about a concept that's straight out of science fiction, but is rapidly becoming a hot topic in science reality: terraforming other planets. Imagine stepping onto Mars or Venus and breathing fresh, Earth-like air, feeling grass beneath your feet, or seeing oceans shimmering under alien skies.
It sounds incredible, right?
But how close are we to making this dream a reality? Terraforming, essentially transforming a planet's hostile environment into one suitable for human life, is an idea scientists, engineers, and dreamers have pondered for decades. But how exactly do we go about doing something as ambitious as altering an entire planet? Is it possible with the technology we have now, or is it something we'll only achieve far into the future? Let's begin our cosmic journey with our neighbor Mars, often considered the best candidate for terraforming. Mars is cold, dry, and bombarded by harmful solar radiation. Yet beneath that harsh exterior lies great potential. The key challenges include warming the planet, creating an atmosphere thick enough for humans to breathe, and protecting that atmosphere from being stripped away by solar winds. One common approach scientists have discussed involves warming Mars by triggering a greenhouse effect, much like the one we're desperately trying to mitigate here on Earth. How could we do this? One idea includes releasing powerful greenhouse gases into the Martian atmosphere, gases like methane or sulfur hexafluoride, which would trap heat and gradually raise temperatures. Another method involves placing massive orbital mirrors around Mars to reflect sunlight onto the planet's surface, warming it slowly over centuries. But even after raising temperatures, Mars's atmosphere would still be very thin. We need to generate an atmosphere dense enough to support human life. To achieve this, scientists suggest tapping into the vast reserves of carbon dioxide locked in Mars' polar ice caps and subterranean ice deposits. By gently heating these regions, perhaps through directed solar energy or nuclear power, we could release stored gases into the atmosphere, slowly thickening it to sustain life. However, there's a catch. Mars lacks a significant magnetic field, meaning any atmosphere we create could quickly get blown away by solar winds. To counter this, some visionary scientists propose placing giant magnetic shields at strategic points in Mars's orbit, creating artificial magnetic protection. Think of it as placing a massive cosmic umbrella over the planet, deflecting solar radiation and safeguarding the atmosphere. Now, terraforming Mars sounds complex enough, but what about Venus, our other planetary neighbor? Venus, often called Earth's sister planet, poses even greater challenges. Its atmosphere is thick, crushing, and dominated by carbon dioxide, with temperatures hot enough to melt lead. Yet, incredibly, some scientists think Venus might also be a candidate for terraforming, though through radically different methods. To tame Venus's runaway greenhouse effect, we could try a technique known as atmospheric thinning. One speculative yet exciting idea involves using vast fleets of solar-powered drones to convert atmospheric carbon dioxide into solid carbon, gradually thinning the thick atmosphere. Another approach could involve introducing large quantities of hydrogen to react chemically with Venus's carbon dioxide, forming water and reducing atmospheric pressure and temperature significantly. However, Venus's rotation is extremely slow, taking 243 Earth days for one rotation. This means that even if we manage to cool it down, we might still have to deal with a world where daylight lasts for months. Could humans adapt to such extreme day-night cycles, or might we attempt to alter Venus's rotation itself? Believe it or not, changing a planet's rotation speed is theoretically possible by precisely calculated asteroid impacts or by deploying gigantic orbiting solar sails. However, such feats would demand energy and engineering beyond our current capabilities. Let's briefly consider moons as well. Titan, Saturn's largest moon, intrigues scientists because it already has a thick atmosphere, rich in nitrogen, with vast oceans and rivers made of methane. While its extreme cold and lack of breathable oxygen present substantial obstacles, terraforming Titan might involve heating the surface and creating an oxygen-rich atmosphere through chemical reactions. With sufficient technological advancements, Titan might someday become a distant second home for humanity. As fascinating as these scenarios sound, terraforming isn't without ethical concerns. Many scientists and ethicists debate whether humans have the right to fundamentally alter other worlds. Would terraforming erase precious scientific information that these planets could provide about the origins of life and the universe itself? Could we inadvertently destroy potential alien ecosystems, no matter how microscopic or simple? Despite these questions, the idea of terraforming captures our imagination precisely because it blends ambition, curiosity, and survival. As Earth's population grows and our planet faces environmental pressures, exploring ways to extend humanity's reach into the cosmos becomes increasingly relevant. Ultimately, while terraforming might not happen in our lifetime, the research and thought experiments underway today could lay the groundwork for future generations. By studying how to engineer planetary climates, atmosphere dynamics, and ecosystems, we not only move closer to potentially colonizing other worlds, we also gain invaluable knowledge about protecting and managing our own planet Earth. So could we terraform other planets? With enough time, resources, innovation, and perhaps a little cosmic luck, yes, we absolutely could. The real question is, should we? And if the answer to that becomes yes, then the greatest adventure in human history might be just beginning. Thanks for joining me today, and as always, keep looking up.